We'll do some reading. Oh, all right, thank you. All right, Lois, can you read factor theorem, please? Guys, quiet so we hear Lois. Good. All right. Yeah, they have to stop. Stop making us laugh. All right. keep going. All right. It's all recorded. It's funny. Let's go. Okay. Factor theorem. Guys, quiet.
And if x minus a is a factor of the polynomial, then x equals a is a 0 of the polynomial.
Thank you. So we know the connection. If we have a solution, the factor is x minus that number. So if x equals 4 is a 0, x minus 4 is a factor, right? We know this. So here, -3, 2, 1 plus minus I root 7, those are zeros that polynomial. Great. What that means is that these are all factors. Okay. So how to verify them? How many different ways can you do that? You could FOIL, right? That's probably one way you can do it. But here's what I prefer you guys do. I'll FOIL these two first, because that's kind of easy. If you FOIL that, what do you get? X squared. The first two, x plus 3, x minus 2, if I FOIL it. And then the middle becomes x, right? Good.
What did you do?
So FOIL. Now here's, and this is, you guys probably forgot this because we haven't done this in a while. You could FOIL this as well, but I wouldn't do that. And mainly because it's nasty. Even better than that. Here's what I do. FOIL or back solve.
What is that?
Oh, and this is that on the homework or something?
I think.
I hated it. Actually, I liked it better than foiling because
Thank you. Yeah, because it's a strong word. Okay. All right. Anyway, back solve. Here's how you back solve. You know this is true, right? Guys, quiet, please. Hold that. X equals 1 plus minus I root 7. So, how do you back solve? Can I talk? Thank you. X minus 1 equals plus minus I root 7. So what you're doing is you're slowly getting it to a factor. Now, if you have a radical on the right side that's isolated, what should I do to both sides?
Square.
Square. Good. Yep. So x minus 1 squared. And if you square a positive or a negative, it's still positive, so that just goes away. You square I squared, of course it's I squared. And square root 7, it's 7. Now, this is where we got to be careful. What's I squared again? Yeah, so it's -7. And I'll FOIL the left side while I'm at it. And now I'm almost there. Move the -7 over from right to left. What do you got? X squared minus 2x plus 8. Correct. Good. Okay, it's still a bit of a pain. You can't really avoid this. But in order to verify that these factors multiply to p of x, you'd have to FOIL again. But that's where then I would then use a box. But here's the thing. Just have faith that you're doing this right. Because what's -6 times 8?
24.
48.
-6 times 8, -48.
Yeah.
You did -3 times 8. It's okay. What's x squared times x squared?
6.
X
X to the 4.
Yeah, so no.
X. Yeah.
Is there a word? Is there a word for them?
Quartic. Quartic.
What about 5?
I don't know. Just say degree 4. Maybe. But anyway, we see that this is going to work. So you could FOIL again if you wanted to, but I trust that this will work out just fine. So what this leads us to, I know it sounds kind of weird that we're talking about it so far in Algebra 2. You should have been talking about middle school. Because middle school, you guys start learning about algebra. The fundamental theorem of algebra. Okay, yeah, because COVID, whatever.
Nope.
No. All right, whatever. Okay, it sounds very rudimentary. Like, okay, it's fundamental. How can I learn about this earlier? Here's all it says. Guys, quiet, please. This, in a nutshell, there's all these fancy words. I'm just going to tell you what it really means. The degree equals the number of solutions. And when I say solutions, real, complex, or repetitive, Because-
Oh, like freedom.
like bouncing,
What?
like double roots or triple roots. So, for example, if I have y equals x plus 3 cubed, we call that a triple root, right? Because if you think about x plus 3 cubed, how many times does the x plus 3 show up?
3 times.
3 times.
It's repeating.
So x equals -3 with a multiplicity of 3.
Did we learn them?
I don't think I've taught the word multiplicity to you guys. Multiplicity just means how often something happens.
So would this also be like a square?
Sure.
So why can't you
What if I had this? If
Why
x
can't you
is a
just do x?
multiplicity.
I can just do x equals -3 cubed.
No. What I'm doing is I'm just telling you what the solutions are. No, if you have x plus 3 raised to the third power, just you have x plus 3 times. So it's -3, -3, -3. But all I'm trying to say is that the degree of the function will equal the number of solutions, whether it's real, complex, or repetitive. So in this case, right, what's the degree for p of x for this new p of x here?
30.
So I expect 3 answers. Okay. But some of the answers might be repeated. So you have -1, great. But 2 happens twice, it's a double root. So it's -1, 2, 2. So these are my 3 answers, and that should line up with the degree. So what we're trying to relate this to are the factors that we write. How often those factors happen has to line up with the degree of the function. That's a fundamental theorem of algebra. There's all these fancy words, but in a nutshell, that's what it is. So let's look at 8.137. John, can you read that part for each of the following, whatever?
For each of the following descriptions of polynomial functions with integer coefficients, answer the question: what are the possible numbers of real zeros? How many complex zeros are possible?
Okay, this is actually important. It says integral coefficients. That means that, let me get a text box. That's probably better because there's too much handwriting here. Integral coefficient means the number in front of each variable is an integer. That's what it means. So no fractions or decimals. That's what it means. So if you have degree 3, y equals x cubed plus blah, 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 whatever, right? How many real zeros could I have?
3.
3, yeah. You get 3 real zeros. Okay, great. Now, how about complex zeros? This is tricky. You could have 0 complex. That's possible. With 3 real.
1 and 2.
Can complex numbers come in odd numbers or do they have to come in pairs?
So 2 and
You can have 2 complex
1.
and 1 real. Because remember, when you have a complex 0, what must also be a 0? Its conjugate, right? If you have 1 plus I, what's also a 0? 1 minus I. Why did it come in pairs? Think about it. The i's need to, yeah, you need the i's to cancel out. Exactly. Like if you have like 1 plus I as a solution, you can't just leave that alone. You have to have it with a pair so that when you actually were to FOIL it with its factors, the i's will go away. Otherwise, they won't go away. And you have I as a coefficient of x. That's a problem. We can't have that. So it could be 0 complex with 3 real. And sorry, I meant to say 2 complex with 1 real. Complex numbers must come in pairs. Always, 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 always. They must come in pairs. So for a 4th degree, here are the options. I got 4 real, or you can have 2 real with 2 complex, or you get 4 complex. Yes, must always come in pairs. And I'm running out of space here. Let me show you graphically what's happening, because that's also kind of important too. Okay, let me draw 3 different graphs. And this is huge because this is now connecting algebra to graphs. Okay, this is huge. How many x-intercepts do I have here?
4.
4. 4 real. Nice. How many x-intercepts do I have here?
2.
2. 2 real, 2 complex. And think about, how do I know this is degree 4? Because I have 3 turning points. 1, 2, 3. Peaks and valleys. Here. Do I have any any x-intercepts? No. So no real x-intercepts. But because of the 3 turning points, 1, 2, 3, you have 4. You have 4 solutions. However, they're all complex, right? So that's how it could look. So this goes with this. This goes with this. And actually, the more I think about it, I think that's a lovely test question. So we'll talk about that next week. Haven't written the test yet, but I think it's a great way to, yeah, or maybe the final. Okay. For 5th degree, they gotta come in pairs, right? The complex ones must come in pairs. So you could do 5 real, or you could do 2 complex with how many real? Or you could do 4 complex with 1 real. It must always come in pairs. That way you guarantee the I goes away and you have integer coefficients. Otherwise, you will not have integer coefficients. You have I, and that's a problem.
Or like, ever like when we have to figure out how many like types of solutions are, like, is there like an
No.
equation for that?
Okay. You don't need to worry about that. Okay, let's keep moving, guys. And these notes shouldn't be too bad today. Okay, next up, integral zero theorem. It's pretty much what I've been saying. If you have an integer as a 0, then it must be a factor of the constant term. So if A, B, and C are the zeros, and if they're all factors of the constant, then the constant term is divisible by A, B, C, and D. That's what it's saying. What was that? So for each number of possible real zeros, give an example in factored form. What is a constant term? Not sure what they're yeah, that seems kind of really open-ended. Give me a sec here. Let me make sure I understand these notes. For each number of possible real zeros, give an example. Okay, this one should be pretty straightforward. Not sure what they're, yeah, it just seems okay. I'm just gonna write some stuff. Yeah, it seems kind of so, I'm a little puzzled by what this question is asking, but it's all good. Okay, that makes sense, right?
Why is it plus 2 and not 9?
I just felt like doing that.
Alright.
Yeah. So what is a constant term? So in this case, I'd have x cubed plus dot dot. Oh, I get it now. Okay, I get it. Here's what we're trying to do this example. I'm giving you something that has a bunch of factors, right? So it's a bunch of factors here. And I'm going to expand it, but I'm not going to expand it fully. I'm just going to give you the first term and the last term. Do you see why the first term?
Wait, why is
Yes,
it why
yes.
is it negative 6?
Yes, because I'm going too fast. That's why. It's plus 6. Thank you.
Wait, why?
It's plus 6 because you're doing -1 times 2 times -3. You multiply 2 negatives.
Oh yeah.
Now, why am I doing this? Because we'll see that all these numbers here are factors of 6, right? Aren't 1, 2, and 3 all factors of 6?
Sure.
Yeah, that's the point of this example. I was a little confused at first when I saw this problem. I was like, wait, what's going on here? Okay, I'll do a 4th degree polynomial, and we'll say we'll do y equals x plus 2 again, x minus 3. We'll do x plus 4, and what the heck, we'll do x minus 5. Okay, sorry, some big numbers there. What's gonna be the degree here, by the way? X what power? Good. Plus dot dot dot. And I'm gonna do this by head. -6 times -20. That's positive 120, I think. Okay. Are each of these numbers 2, 3, 4, 5? Are each of them factors of 120?
Yeah. So what are we supposed to do for this?
You'll see in a moment. That'll be on the next page. And then fine for a fifth degree, you get the idea. We'll just move on to the next page. Okay. Next page, the remainder theorem. Okay. So we talked about division, right? Now, what if the division is not clean? What if it doesn't come out clean? So, like, for example, what's the constant term here? Negative 48. It's 48 divided by 5. So we expect the remainder. Okay, great. So if you were to plug in 5,
P5 equals 5.
and actually, let me do this. You guys don't have to write to say, guys, just watch. But the next example, 8, 140, I want you to
Why is
work out.
P5 equal?
I'm gonna explain in a moment.
5 and 48?
I'll explain. Okay. So first off, if you plug in 5, right, into the function itself, you wind up getting this. 5 to the 4 power, 5 cubed. You guys would agree this is what we have to do, right? And that'd be 625 minus 125 plus 100 minus 48. So it's 500 plus 52. And guess what? You get 552. Okay, you could do all that. Or you could do this. And that's just direct substitution, by the way. Let me move this up here. Okay, so that's called direct substitution for obvious reasons, right? Okay, what if I decide to divide? Okay, so we know how this division works. We've done it a handful of times now, right?
Oh, because of it.
So what if I divided this polynomial by x minus 5? Now I'll put x4 here. Okay, now it's good review of what we've done recently. What do I multiply x to get x4? Perfect. Negative 5x squared. No, negative 5x cubed. Now I have negative x cubed in the polynomial. What do I add in negative 5x cubed to get to negative x cubed? Good, thank you, Lincoln. 4x cubed. And of course, 4x squared. And I'll just keep going because you guys get the idea. Negative 20x squared. I have no x squared, so 20x squared. 20x. Negative 100x. 80x, I think. Is that right? Yep. And that'd be 80 and be negative 400s. Okay, so it's a little wait.
Never mind.
Wait, did I do it right?
No, it's 4x cubed.
How do I know? Because 4x squared times x is 4x cubed. But let me make sure I did this all correctly. Because I multiply 4x squared to x to get the 4x cubed. And then I'm supposed to get no x squared. So if I get negative 20x, get 20x squared, I could get 20x, negative 100x. Oh, I made a mistake, guys. My apologies. It shouldn't be 80x. What do you have to add to negative 100x to get the positive 20x? What do you have to negative 100 to get the positive 20? Yeah, 120. I messed up. My bad. Yes, negative 600. Okay, now I feel better about that.
How is that easier than the first one?
Well, here's the deal. This is the connection we're going to make. What do you have to add to negative 600 to get to negative 48? You have to add 552. That's a remainder. What this tells us is that the remainder from the division is the same thing as plugging in 5 into the function. So if x minus 5 is being what you're divided by, assume that 5 is an x-intercept, even though it's not. Assume it is. When you plug it in, you don't get 0, instead you get 552. So what this tells me is that the remainder is the same thing as plugging that number into the function itself. So the remainder theorem states that for any number c, when polynomial p of x is divided by x minus c, the remainder is p of c. Whatever this number is, plug into the function itself, that's the remainder. Now, what if it's not? What if it's clean? Then it'll be 0. Then great. As it should be a factor. And we see that over here as well, right? So now let's wrap this up, and then you guys can redo quizzes or do homework or study for APs, which I'm totally fine with. Bless you. Okay, so P of 2. Here we go. P of 2 is going to be 2 cubed minus 6 times 2 squared plus 7 times 2 plus 2. If you work it out, what do you get? You get 8 minus 24 plus 14 plus 2. Okay, comes out 0. So there's no remainder.
Why would you use the remainder?
So what it means is that since P of 2 is 0, actually, let's think like this. Since P of 2, then x minus
Two.
blank is a factor. X minus what, guys? X minus 2. Good. That's called the factor theorem, by the way. You guys just did the factor theorem here. So that's part B. Now, find another factor. We got to divide. Unfortunately, this is not factor by grouping, so you have to do the division like this. I've not taught you guys long division because I think it's a pain in the ass. So we're not going to do it. Unless if my other colleagues are, then I'll let you know on Friday if we have to do it. So we multiply x, get to x cubed, x squared. Negative 2x squared. What do you add to negative 2x squared to get to negative 6x squared? Perfect. Thanks, Tamara. And then that'd be negative 4x. That'd be positive 8x. Hope I don't make another mistake. Negative x, negative 1, positive 2. Lovely. That's what it should be. And then, of course, that's weird. So how do I handle weird? X squared minus 4x minus 1. How do I handle that? How do I solve that? The quad form. Correct. And I'll do that in red. So for part D, x equals 4 plus or minus b squared minus 4ac all over 2a, which should be 4 plus minus root 20, I think. And I do care about simplifying radicals. We've talked about in the past. 4 plus minus 2 root 5 over 2. What happens when you divide the whole thing by 2? You get that. And by the way, you can always verify this in a graphing calculator. So if I ask this question on a test, I would allow.
What's the point? Like, what does that even show?
Yeah, they're the x-intercepts. It's just they're being wacky. It's 2 plus root 5 is like 4.2 something, and 2 minus root 5 is like negative 0.2 something. I think I don't know. But
X equals that.
but you can always graph in the calculator, do those cross the x-axis and see the decimal equivalents by actually computing these in the calculator. Oh, what's 2 plus root 5? 2
We
minus.
just got like how section.
I would allow in a calculator. I would be
Okay,
fine
why
with it
can't we just plug into the big one?
because I want the radical answer. The calculator won't give you the radical answer. That's why.
Is there any calculator that can do that? Just want like
Yes, I think TI Inspire, maybe, perhaps. I don't know.
every-
So, was that?
can you use it?
They still show me the work, and it's a really hard calculator to figure out. So, anyway, so we're all done. So quizzes. Okay, let's go.